The aim of this lecture is to give an overview of modern telecommunication networks in terms of architecture and required performances. After this lecture, you will be able to understand how current end-user applications based on voice, video, and data have driven the evolution of telecom network infrastructures. The evolution of modern telecommunication networks is driven by the enormous growth of data traffic generated by very different types of end-user requirements. Today, these digital networks are a highly sophisticated mix of a plethora of different softwares used at all levels in the network, hardware infrastructures such as servers, switches, and routers placed in central offices, and physical links between central offices and toward final users, using wireless radio links or wired solutions based on copper or fibers. In this lecture, we will focus on the architecture and requirement of these networks. In modern countries, a solid, well-designed and capillary telecommunication infrastructure is just as important as other national commodities, such as road or railway transportation systems, and should be one of the key national policies. We can draw a parallel to the transportation system to understand this point. The road and highway infrastructure are typically developed inside national public plans, while cars and trucks are privately produced and owned. Similarly, the development of a modern digital network infrastructure must be seen as a very important national strategic target that needs a nationwide plan and, often, public funding. This is true particularly in developing countries. Meanwhile, the end-user applications and devices, such as modems and smartphones, can be left to private and shorter-term initiatives. National and international telecom infrastructures are usually organized into three geographical segments, which I will now describe. The segment that we see in our everyday lives is the so-called access network. It is made up of all the wireless or wired links that connect our houses and our mobile devices to the closest telecom operator's central office. It is also called the last mile segment, having a typical distance from a few hundred meters up to a few kilometers. Different central offices inside the same urban areas are then typically connected in ring-like structures and constitute the metro network segment. Finally, different cities are connected by links that are usually based on optical fibers spanning from hundreds to thousands of kilometers. This segment is typically called the long-haul network or the core transport network. Each of these three segments, access, metro, and long-haul, have very different techno-economic requirements. For instance, the access segments for both its mobile and fixed parts needs to be as capillary as possible and is thus the more heterogeneous from a technological point of view. To better understand the different requirements of each network segment, we focused on one of the most important technical metrics, the bitrate to be transported. Bitrate is the digital equivalent of the amount of water in liters per second that flows in the pipes of an aqueduct. Specifically, the bitrate is the number of bits, ones or zeros, to be transported per second. Let's have an overview of the bit rates generated by the applications that we use in our everyday life. A voice signal, after being converted to a digital stream of ones and zeros, requires approximately 10,000 of bits per second. We can say, for instance, that during a phone call you generate about 10 kilobits per second. An audio signal having good musical quality requires a higher bit rate, which, after compression techniques such as the famous MP3, is about 100 kilobits per second. A good quality video requires even a higher bit rate. A typical television standard quality video after MPEG compression requires a few megabits per second, while ultra-high definition video requires up to some tens of megabits per second. In fact, today video-based applications are generating the largest part of digital traffic in terms of overall bitrate. Any other applications typically require much lower bitrate per user. This includes all typical web browsing, but also the so-called Internet of Things that, even though can often be seen as much more strategic than video entertainment, generates much lower traffic in terms of bitrate. The trend toward higher and higher bitrate requirements is driving the evolution of modern networks. As individual users, we would like to have dedicated connections giving us bitrate up to the tens or even hundreds of megabits per second, as required by high-quality video streaming. Imagine the impact of these new requirements compared to the old pre-2000 network, which was largely built to satisfy only phone calls requirements. That is, tens of kilobits per users. If the access network is dimensioned to support tens of megabits per second per user, the metro network that has to aggregate the traffic for millions of users has today to handle hundreds of gigabits per second per link. Long-haul networks, which further aggregate the traffic between cities, easily need to handle tens of terabits per second per link. In this lecture, we have pointed out the importance of a well-structured nationwide digital network and discussed its typical architecture and its dimensioning in terms of bitrate. In the next lecture, we will overview the actual transmission technologies that support these bitrates.